Good evening, students. In the last period, we have studied exercise problems on the chapter real numbers, and also we have studied different types of questions which will come for exam. That is the type of the questions we have studied. Now we shall study very important problems which have appeared in previous year question papers. Those which have appeared repeatedly. Let us see this example. Prove that square root of 2 is irrational. It has appeared in 2020, 2022, 2024. It's a very important problem. Already we have discussed the solution of this question in previous class. Just once again I'll just write very important steps. Remaining steps I'll explain and important steps I'll write. Okay, students. Here, to prove square root of 2 is irrational, we are following contradictory method. Contradictory method means it is told to prove irrational, but we take it as a rational. First, initially we assume it is a rational number. So let us assume square root of 2 is a rational. If it is rational, we must be able to write in the form of p by q. So we can write it in the form of p by q. What are p and q? P is integer, q is also integer. P and q are integers. And the denominator q should not be 0. Means here p comma q belongs to I, q is not equal to 0, and p comma q equal to 1, that is p and q are co-primes. Okay, students. Now squaring both sides. If we square both sides, 2 equal to p square by q square. Therefore, p square equal to 2q square. Now, p square is divisible by 2. P square is divisible by 2. In previous lesson, in detail, I have explained how it is divisible by 2. Now, I'll write p square is divisible by 2. If p square is divisible by 2, p is also divisible by 2. Okay, if p is divisible by 2 means 2 into some quotient here gives 0 remainder. P is divisible by 2. So quotient we can take as m. What is m? M is some integer. So p can be written as 2m. P equal to 2m. Now we will call this as 1. Substituting p equal to 2m in 1. I am going to substitute, or I am going to put the value of p in 1. P place I will put 2m. So 2m bracket square equal to 2q square. So this becomes 4m square equal to 2q square. 2 1 ja, 2 2 ja. So I'll write q square equal to 2m square. What is m? M is some integer. Here q square equal to 2m square. Similarly, q square is divisible by 2. So q square is divisible by 2. If q square is divisible by 2, then q is also divisible by 2. Q is also divisible by 2. What is the meaning? P is divisible by 2. P is divisible by 2. Q is also divisible by 2. Therefore, both P and Q have common factor. If both P and Q have common factor, P and Q are not co-primes. We have assumed P and Q are co-primes. Now P and Q are not co-primes. If P and Q are not co-primes, our assumption is wrong. If our assumption is wrong, then square root of 2 is irrational. Therefore, what? Both P and Q have common factor 2. In the next step, therefore, P and Q are not coprimes. Therefore, P and Q are not coprimes. Next sentence you should write. P and Q are not coprimes. Therefore, our assumption is wrong. If our assumption is wrong, then what? Square root of 2 is irrational. So, next step here I will write. Both P and Q have common factor 2. Therefore, P and Q are not coprimes. Therefore, our assumption is wrong. Our assumption is wrong. Therefore, square root of 2 is irrational. Square root of 2 is irrational. Okay, students, you might have understood the steps. In the same way, they will ask, show that square root of 5 is irrational, square root of 7 is irrational. This way they will ask. Okay, students, you need to practice this. There is a chance of asking this question. Next important question is, this is the next important question. Second one, prove that square root of 3 plus square root of 5 is irrational. So this question is asked in the year 2021, 2023 and 2024. In different years it is asked. This is also important question. We should follow the same method. Here, let us assume that square root of 3 plus square root of 5 is rational. They have told to prove irrational. We are assuming rational initially. Okay, if it is rational, we must be able to write in the form of P by Q. Therefore, square root of 3 plus square root of 5 can be written in the form P by Q. Where P comma Q belongs to I, Q is not equal to 0, and P and Q are coprimes. We are assuming this way. Okay. Then now squaring on both sides. Squaring on both sides. So square root of 3 plus square root of 5 bracket square equal to P square by Q square. Here many students do mistake here. They will write square of 3, square of first term, then square of second term. They will write 3 plus 5 equal to 8. That is wrong. Here it is a plus b whole square form. We know a plus b whole square is a square plus 2ab plus b square. So using this ID, we can expand this. So a is square root 3, b is square root of 5. If we use that, first term square, a square, first term square, plus 2ab, 2, a is square root of 3, b is square root of 5, plus b square, second term square, square root of 5 bracket square, equal to p square by q square. Now square root of 3 square is 3 plus 2 root 3 5 is 15. 3 square root of 15 plus square root of 5 bracket square, meaning square root of 5 bracket square, meaning square root of 5 into square root of 5. Square root of 5 into square root of 5 is 5. So 5 equal to p square by q square. Now 3 plus 5 is 8. 8 plus 2 square root 15 equal to p square by q square. Next step. Now I'll take 8 on RHS. So 2 root 2 square root of 15 equal to p square by q square minus 8. Taking 2 also to RHS. Square root of 15 equal to 1 by 2 into bracket p square by q square minus 8. Now here students, p square by q square, p square by q square is a rational number. P square by q square is a rational number, and 8 is also rational because it can be written as 8 by 1. It is in the form of p by q. It is a rational. Rational minus rational is rational. Rational into 1 by 2. 1 by 2 is also rational. So rational, this part is rational. Rational 1 by 2, that is also rational. So RHS is rational. RHS. But LHS, see this side, square root of 15 is irrational. LHS is irrational, RHS is rational. This is not possible. So our assumption becomes wrong. If our assumption is wrong, then square root of 3 plus square root of 5 is rational. So here next one more step we should write. Here 1 by 2 into bracket p square by q square minus 8 is a rational or is rational. Is rational. But we know square root of 15 is irrational. Is irrational. Left hand side irrational, right hand side rational, not possible. So we should write next sentence. This is not possible. This is not possible. I'll write next line. I'll check whether it is visible or not. Visible. So what we can write next? This is not possible. This is not possible. This is not possible. Next sentence. This happened because of our wrong assumption. Because of our wrong assumption. Therefore, what is right? Right is, therefore, square root of 3 plus square root of 5 is rational. Is rational. Okay, our assumption is rational. What was our assumption? Our assumption was square root of 3 plus square root of 5 is rational. But that assumption is wrong, means square root of 3 plus square root of 5 is rational. This is how we can prove. Next question. Next question is third one. Without actual division, without actual division, determine if 64 by 1250 has a terminating expression, terminating expression, not expression, expansion, terminating expansion. Okay, students. This question is asked in 2020, 2021, 2023. Students, same question they may not ask, but similar question they will ask. Same concept. So what is asked here? First we need to understand. They have asked, if you divide 64 by 1250, whether you get terminating decimal or non-terminating decimal, which kind of decimal you get, they are asking. Understanding? So other example I'll give. If you divide 10 by 3, which kind of decimal you get? 10 by 3. 3 3 is how much? 9. 1 remaining. Here you can put 0 and take down 10. 3 3 is 9. 1 remain. Again you will take 0. 3 3 is 9. Again 1 will remain. Again you will take 0. 3 3 is 9. So there is no end. 3.333. There is no end. This kind of decimal we call this as a non-terminating and recurring decimal. Non-terminating. Here 3 is repeating again and again. Recurring means repeating. It is a non-terminating. It is not stopping. There are no countable digits after decimal point. Uncountable are there. Therefore, we call it as a non-terminating, but same digit is repeating again and again. So 3.3 bar we write non-terminating and recurring decimal. Okay. Here they are asking you, without actual division, we should not divide like this. We should not divide like this. 10 by 3 I divided. No, that way we should not divide. Without dividing, we should tell whether 64 divided by 1250 is terminating or not. So given number is what? Given number is 64 divided by 1250. This altogether one number. It is a rational number. It is in the form of P by Q. To check terminating or not, first anything common is there, we should cancel. I am going to cancel 2 3 za, 2 2 za, 2 6 za, 2 2 za, 1 remaining 2 5. Now 32 divided by 625. 32 and 625 both will not come in the same table. There is nothing common now. Okay. We should express 625 in exponential form. 625 can be written as divided this by 5. 5 ones are 5 is a 5 5. 5 25 are 5 5 are 5 1 are. So 32 can be written as 5 raised to 5 raised to 4. 5 raised to 4. If the denominator is in the form 2 raised to m into 5 raised to n, if the denominator is in this form, so that number is a terminating decimal. Now denominator, is it in this form? Yes, it is in this form. 5 raised to 4. Here 5 raised to 4. N place 4 is there. Value of n is 4. What about 2? 2 raised to m. You can write 2 raised to 0 here. 2 raised to 0 means what? 2 raised to 0 is 1. So 1 into 5 raised to 4 is again 5 raised to 4 only. So here m value is 0, n value is 4. Here 32 divided by 2 raised to 0 is 1 into 5 raised to 4 means 5 raised to 4 only. Just I wrote in that form. So now what we can say, denominator is in the form 2 raised to m into 5 raised to n, where m and n are non-negative integers. If denominator is in this form, then it is terminating decimal. Therefore what? Therefore 64 by 1250 is a terminating decimal. This is how we can check. First, what we should do in this kind of problem, whether numerator and denominator anything common is there, we should check. If common is there, cancel it. After cancelling, express the denominator in this form. Prime factorize and check whether there are only two factors, 2 and 5. If 2 and 5 are there, or if only 5 is there, or if only 2 is there, then terminating. Otherwise non-terminating. Any other factor comes, non-terminating. Understood, students? We shall go to next question. Next question is similar. Next question is also similar. Next question is fourth one. Without actual division. Again, without actual division. Question number 4. Without actual division. State without actual division. State whether 343 divided by 1500 is a terminating decimal, is a terminating or non-terminating. Okay, this question is asked in the year 2022 and 2024. Okay, students. Now, Here, given number is 343 divided by 1500. Is this number divisible by, means is there anything common? First we should check. Is there anything common? Is it divisible by say 3? No. Is it divisible by 2? No. It is divisible by 7. You see here. 343 divided by 7. If you do 7 for the 28. So 6 remaining 3. 7 9 the 63. 0 0. And 7 into 49. Further you can write 7 into 7 into 7. So in 343 there is a factor 7, only 7. But this is not divisible by 7. 1500 is not divisible by 7. 7 2 is 14, 1 remaining 0. 7 1 is 7, 3 remaining 0. 7 4 is 28, 2. Remainder 2 is remaining. Therefore, both numbers are not having any common. These both numbers 343 and 1500, they have not a common factor. Already these are co-primes. Now what we should do? We should express denominator. We should prime factorize the denominator. Here you take 1500, go on dividing. It is divisible by 2. 2 7s are 14, 1 remaining. 2 5s are 10, 0. Again by 2. 2 3s are 6, 1 remaining. 2 7s are 14, 1 remaining. 10. 2 5s are 10. Now it is divisible by 3. 3 1s are 3. 3 2s are 6, 1 remaining. 3 5s are 15. Now divisible by 5. 5 25s are 5 5s are 5 1s are. So 2 appeared 2 times, 3 appeared 1 time, 5 appeared 3 times. Okay. Now denominator is not in the form, required form. What is the required form? 2 raised to m into 5 raised to n. Here 3, prime factor 3 has appeared. If it has to be terminating decimal, prime factor 3 should not appear. Only 2 and 5 should appear, or only 5 should appear, or only 2 should appear. So just what we can write? The denominator is not in the form 2 raised to m into 5 raised to n, where m and n are non-negative integers. Non-negative integer meaning, students, for example, see here, natural numbers start with 1 2 3 and so on. Whole numbers 0 1 2 3 and so on. Integers -3 -2 -1 0 1 2 3 and so on. If I say non-negative integers, leave these negative integers, remaining means 0 1 2 3 4. Non-negative means whole numbers, means 0 also comes there. Okay, students. So here denominator is not in this form. Why? Because 3 extra it has appeared. Therefore what? Therefore 343 divided by 1500 is non-terminating decimal, you can write. non-terminating decimal. Its decimal expansion will be non-terminating. Okay. Next question. Question number 5. Question number 5 is find the prime factorization. Find the prime factorization. Find the prime factorization of the denominator of denominator of 105 divided by 1250 and state whether and state whether the decimal expansion decimal expansion terminates or not. Okay students, same method. Here it is told find the prime factorization of the denominator of 105 divided by 1250 and state whether the decimal expansion terminates or not. So directly we should not find a prime factorization of this. First, is there common between numerator and denominator? We should check. So what is given? They have given 105 divided by 1250. Cancel here. 5 2 za 5 1 za. Here 5 2 za 10 2 remains. 5 5 za 0. Now 21 divided by 250. Now prime factorize the denominator. Denominator is 250. We shall prime factorize. Start dividing. 2 1 za 2 2 za 2 5 za. Now not divisible by 2. Start with 5. 5 2 za 10. 5 5 za 5 5 za 5 1 za. So this is equal to 21 divided by 2 appeared one time, 2 raised to 1. 5 appeared 3 times, 1, 2, 3. So 5 raised to 3. Here the denominator is of the form which form denominator is of the form 2 raised to m into 5 raised to n. Denominator is in this form. Therefore, it is terminating decimal. Where what are m and n, that also we should write. Where m and n are non-negative integers. Okay. If denominator is in this form, then it is terminating decimal. Okay. It's therefore given number 105 divided by 1250 is a terminating decimal. Okay students, you have understood. Next question. Question number 6. Question number 6 is, if two numbers have if two numbers if two numbers have HCF, highest common factor equal to 13, LCM, least common multiple equal to 455, and one number is and one number is 65, find the other number. Find the other number. Find the other number. This question is asked in the year 2020. It is also asked in 2022. Okay, students. It's a very simple question. We know HCF into LCM equal to product of numbers A into B. A is one number, B is another number. Product of the numbers equals HCF of A and B into LCM of A and B. HCF into LCM. They have given HCF 13, LCM 455 equal to A into B. One number is given 65. Another number not given. You can write B or X. You can write. Another number I don't know. I'll write X. Or you can write B only. So therefore B equal to what? 13 into 455 divided by 65. Cancel. 13 1 is 13. 13 5 is 65. 5 1 is 5. 5 9 is 45. 5 1 is 5. So B equal to 91. This is other number. Therefore other number is what? 91. Okay, students. Next question now. Next question is, question number 8 or question number 7. Question number 7. Find the largest number. Find the largest number that divides. Find the largest number that divides 650 and 1170, leaving remainder 5 and 10 respectively. 5 and 10 respectively. It is asked in the year 2023. Okay, students. Now, such number is the number which divides. Such number is the largest number which divides 650 650 minus 5 and 1170 minus 5. I'll explain clearly. This is nothing but the largest number, highest common factor. It is HCF. HCF of 645, 1165. Okay. Before explaining next step, I will take one simple example and I will make you understand. See, for example, if there are two numbers, let us say 12 is one number and 16 is another number. Leave this first. Try to understand this simple one first. There are two numbers, 12 and 16. So here 12 is divisible by 1, divisible by 2, divisible by 3, divisible by 4, divisible by 6, divisible by 12. 16 is divisible by 1, divisible by 2, 16 is divisible by 1, divisible by 2, divisible by 4, divisible by 8, divisible by 16. So 12 and 16 both are divisible by 1, both are divisible by 2, both are divisible by 4, both are divisible by any other number? No. So here 1 divides 12 and 16, 2 divides 12 and 16, 4 also divides 12 and 16. Among this, which is the largest? 4 is the largest. So largest divisor, the largest number which divides both is the HCF, highest common factor. These are all factors of 12. These are all factors of 16. And these are common factors. Among this, which is the largest? 4 is the largest. So largest number that divides 12 and 16 is 4. The largest number that divides 12 and 4 is 16. Okay, now we came to know largest number which divides 12 and 16 is 4. If you divide this by 4, 4 3 is 12, remainder 0. If you divide this by 4, 4 4 is 16, remainder 0. But in this question, they have told remainder is there. Like that, for example, I want largest number which divides two numbers and gives some remainder. If I want remainder 2 here, if remainder 2, if 12 is there, there is no remainder. So something extra should be there here. So extra means 14. It is 14. Okay. Here, if I want remainder 3, here 3 should be more, means 19 should be there. So 14 and 19, if I divide by 4, 4 3 are 12, 2 remainder remaining. If I divide 19 by 4, 4 3 are 4 4 are 16, remainder 3 is remaining, remainder 2 is remaining, remainder 3 is remaining. Okay, I'll come back. If it is asked to find find the largest number, which divides 14 and 19, find the largest number which divides 14 and 19 and gives the remainder 2 and 3. When you divide 14 by that number, remainder should be 2. When you divide 19 by that largest number, remainder should be 3. If the question is like this, how to do? Here are 2 extra is there. Here are 3 extra is there. Okay. This extra 2 remains. Extra 3 remains. So first what we should do, we should find minus 2 from here, minus 3 from here. So 12 here, 16. Now both these two are divisible by same number. There will not be remainder because remainder already we have subtracted. Now I want highest number, that is largest number which divides both. Means I should find HCF. HCF of 12 and 16 is 4. Correct? When you divide 14 by 4, 2 is a remainder. 2 is a remainder. When divide 19 by 4, 3 is a remainder. This is how we have to calculate. Here also like this. Here what we need? We need a largest number which divides 650 and 1170 and gives remainder 5. Remainder 5 in this case, remainder 10 in this case. Okay, 10 means here we should write 10. Okay, students, 10 it is 60. Now find HCF of this. HCF you can find this side. That also in rough side you have to write 645 divide this both number by same number. Both are divisible by 5. I'll write 5. 5 1 is 5, 1 remaining, 5 2 is 10, 4 remaining, 5 9 is 45. Here 5 2 is 10, 1 remaining, 5 3 is 15, 1 remaining, became 10, 5 2 is 10. Now these both numbers are not divisible by any other number. The highest common factor is HCF is 5 only. So it is 5 only. This much is the answer. But students, this question is very different. How different, I'll explain. This question is very different. Highest common factor of these two numbers. Highest common factor of these two numbers is 5. These both are not divisible by any other number. Okay, students. Now, if you cross check, what is the given number? 650. Divide this by 5. 5 1 is 5, 1 remaining, 15. 5 3 is 15, 0 0. Take this 0 down, 0. There is no remainder. Remainder should be 5, but there is no remainder. Okay, students. And similarly, 1170, if you divide by 5, divide by this largest number 5. 5 2 is 10, 1 remaining, 0. Okay. Then take 7 down. 5 3 is 15, 2 remaining. Take this 0 down. 5 4 is 20, 0 0. Completely divisible by 5. Okay. So remainder is not remaining. For in this question, logical answer is 5. Logically answer is 5. It is correct. But if you recheck, remainders 5 and 10 will not come. This question in detail, why, how, what, I'll explain in the next paragraph. Please see the next paragraph. Here, logically this answer is correct. Okay, stepwise it is correct. When you check it back, remainders are not 5 and 10, completely divisible. Completely divisible. Okay, students. Okay. In detail, once again, we shall see this example in the next period. Now, if you want discussion on this particular question, you watch next period. Okay. Question number 8. Question number 8 is smallest number leaving remainder 2 on division by 12, 15 and 20. Okay students, I'll write the step and then again I'll give another example for your understanding. Smallest number divisible by 12, 15, 20 is LCM of 12, 15, 20. Okay students, the smallest number divisible by 12, 15, 20 is their LCM. Already we have studied. Quickly I will make you understand. Here, first what we are doing, we are not thinking about remainder. I want the smallest number divisible by 12, 15 and 20 first. Here, what are multiples of 12? 12 1 is 12, 12 2 is 24, 12 3 is 36, 12 4 is 48, 12 5 is 60. What are multiples of 15? 15 1 is 15, 15 2 is 30, 15 3 is 45, 15 4 is 60. What are multiples of 20? 21 is 20, 22 is 40, 23 is 60. Here 60, 60, 60, 60. This number is divisible. This 60 is divisible by 12 also. 60 is divisible by 15 also. 60 is divisible by 20 also. Means 60 is divisible by 12, 15 and 20. 60 is divisible by 12, 15 and 20. Which is the next number divisible by all these? Next number is 120. 120. Here 120. 120 is also divisible by 12. 120 is also divisible by 15. 120 is also divisible by 20. There are many numbers. Those are all divisible by 12, 15, 20. But we need the smallest one among these smallest. Smallest is 60. 60 is divisible by all these. We need the smallest one. The smallest one is 60. 60 is divisible by 12. 60 is divisible by 15. 60 is divisible by 20. Now, see our students. The number 60 is there, no? This 60 is divisible by 12. 12 5 is 60. Remainder 0. 60 is divisible by 15. Yes, divisible by 15. 15 4 is 60. 0. Remainder. 60 is divisible by 20. Yes, 23 is 60. Divisible. Remainder 0. But what is asked here? Smallest number leaving remainder 2 on division by 12, 15 and 20. Remainder should be 2. I want remainder 2. Here not 0. I want 2. Means I should plus 2 here. This should be 62. Here remainder I want 2. Means here it should be 2. I want to hear means this should also be 62. So what is the required number now? Required number is 62. There should be remainder. There should be remainder 2. Therefore required number is 60 plus 2 extra, that is 62. This is the answer. Okay students, you might have understood. So please watch all videos. Directly if you watch the third lesson, fourth lesson, you don't understand. So on each chapter I have created video around 3-4. Watch all starting from the first, you will understand. These videos are available in Teachmint, that is my account, and also these are freely available in YouTube. My YouTube channel, I will tell you, you can write. My YouTube channel is Teacher at IP Badiger. Search this in YouTube, you will get my photo, click on that and you will get my videos. And please subscribe the channel. And also you can contact me 8050736328. This is my contact number near Golgambas. You can contact for offline tuition classes, that is tuition at my home. Thank you.